This video is solving systems of linear inequalities. We're going to focus on word problems. You can work a total of no more than 10 hours each week at your two jobs. House cleaning pays $5 per hour, and your sales job pays $8 per hour. You need to earn at least $56 each week to pay your bills. Write a system of inequalities that shows the various numbers of hours you can work at each job. So to define our variables, we can use X is house cleaning hours. We can use Y is the sales job hours. So that means that we need to have on our coordinate plane, we're only going to use the first quadrant because we cannot have negative hours and we also can't have negative money. So we'll have X is our house cleaning hours, so we can't have negative house cleaning hours, and Y is our sales job, so we can't have negative sales job hours. So we'll put house cleaning hours, and we'll also have sales job hours. So let's write the system of inequalities. We know that we have two jobs and we cannot work more than 10 hours each week. So our first inequality is X and Y together, X plus Y, cannot be more than 10 hours. So it has to be less than or equal to 10 hours. Our second inequality is based on the money. So house cleaning is $5, so $5 for every X, and we also have $8 for every Y, but we need to earn at least $56 each week. So at least means greater than or equal to 56. Now to graph this, we're going to use, instead of putting them into slope-intercept form, we need to actually determine what our X and Y intercept are. We need to put our scale on here as well. So we know that both sales and house cleaning cannot be more than 10, so we need to just count up to 10. And we should be able to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can just count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll do the same thing here. So this is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So for our first inequality, let's graph this in pink. So X plus Y is less than or equal to 10. So if I were to cover up my X, I would have Y is less than or equal to 10. So I would need my Y value at 10. So I can actually take this and cover up my X and have my Y at 10. So I can have Y value at 10. I can then cover up my Y and have only my X and have my X also go to 10. And then I can just connect those two. I can connect those and have it as a solid line. Connect them with pink. It just needs to be solid, and it will not go below, so I'm going to have it as a segment instead of a line. So I'll start at 10, and I'll go to 10. And I'm not going to shade yet because I want to make sure I can graph my second one. I will graph my second one in, let's go with green. So I'm going to do the same thing. I'm actually going to take my little box here and cover up my x so I can find my y-intercept. So I will divide by 8. 56 divided by 8 is 7. So I'll put on my y, I'll put a 7 there. I'll do the same thing and cover up my y. 56 divided by 5 is roughly 11 and 1/6. So I'll actually 56 divided by 5 gives us 11 and 2/10. So I will graph on my x at 11 and a little past 11. Because what I've done is I've just covered up the values so I can see what my x and y intercepts are. So for my line, I will use a segment, and it will be solid to go from 7 to 11.2. Now I can shade. So for my pink, I need it to be less than that 10. Less than that 10, so I'll have for my pink, I'll have below my pink. All of this below my pink. For the green, I need it to be greater than the 56, so I need everything greater than the green. So the solution set is where the green and the pink meet. This would be the solution set of how many hours we should work for the money. So find the solution set to the system and state one set of hours that you can work to earn enough money. So any coordinate that is within this solution set would work. So let's find a coordinate. Let's go with here. That is 1, 8. So 1, 8 works. Which in this case, x was the house cleaning. So 1 house cleaning and 8 sales job hours. This is one solution that would work because I can't work more than 10 hours, but I have to make sure I make $56 each week. So anything within here would work. I use this block to cover up my x and my y just so I can get coordinates so I didn't have to find it into slope-intercept form, especially when we're dealing with some weirder numbers. That's the reason why I chose to find the x and y intercept. On question 2, it says, Katie is buying plants and soil for her garden. The soil costs $4 per bag and the plants cost $10 each. She wants to buy at least 5 plants. She cannot spend more than $100. Write and graph a system of linear inequalities to model all possible solutions to the situation. So let's define our variables. Let's go with x. We have plants and soil. So let's say x is number of plants. Now let's go with y is bags of soil. So write the system of inequalities. The soil costs $4 per bag and the plants cost $10 each. And we know the $100, she can't spend more than $100. So we know that the 4, the 10, and the 100 should all go together. So our first part of our inequality, so we have soil is $4 per bag and plants are $10 each. So x is going to be the plants. So $10 per every plant plus $4 for every bag. So $4 for every y. She cannot spend more than $100, so no more than $100. So she can spend less than but she can also spend equal to $100. That's our first inequality. Then, but it also says she wants to buy at least 5 plants, which is X. So the X wants to buy at least 5 plants. So she wants to have at least 5 plants. So we can have more than 5 plants or equal to 5 plants. In this case, we have it as only one variable here. So this will be a vertical or a horizontal line. And since it is an X equals, in this case, it's going to be a vertical line. So let's figure out, since we're doing X's number of plants, and Y is bags of soil, let's determine what we should count by. So X's have to go up to at least 5, but what else can the X's go up to? So if I take my block here, I cover up my Y, and I solve for X. So X would be 10. So I need to go up to 10 on the X's. So on the Y's, I need to divide by 4, and I have to go up to 25. So I have to go up to 25 here. So if I count by 2's, I'll get up to 22. So let's count by 2's so that way I can get at least close as possible. So for the X's, we can count by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, the way I did this was I covered up the Y on my first inequality, and I solved for X. The highest value would be 10. And I knew that this one had to go up to 5, so my highest had to be 10, because I solved for X. I then cover up my X, and now I see only my Y. I divide by 4. 100 divided by 4 is 25. So my highest Y value must be 25. Which if I count by 2's, I'll get to 22. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Then we'll have 24 up here, and then 25 will be right above that. So it's not going to fit perfectly, but I can go a little off the graph. So now, to graph them, I'll do my first one in pink. So what that means is I'm going to use this to figure out the exact location. So the reason I do this, for my X, I can solve for X here, I get 10. That's why I put a dot here on 10, and then I will move my box to cover up my X, and that's where I got the 25 from. So I know my other dot will be on the 25, somewhere up here. And that way I can connect these and not have to worry about slope-intercept form. This is called using the intercepts. So for my second one, which I will graph in green, X is greater than or equal to 5. So at the X value of 5 and no Y value, this is going to be a vertical line going up from 5. So I'll graph this in green. So now I can go back to shade. So for the pink, I needed it less than 100. So that's this section underneath the pink. For the next one, for the plants that are more than 5, I need more than 5 plants. So that's towards the right. So I cannot buy more than 10 plants because I knew that that was the highest I could for the money, but I needed to buy at least 5. So the solution set is between here, where the pink and green meet. So we found the solution set to the system. I'm going to highlight it. State one set of plants and soil Katie can purchase. So any coordinate within this location will work. So I can even use, let's go with this coordinate, because it's right in the middle. I can clearly see that it is a good coordinate. It's in the highlight. That's 7, 4. So a good coordinate is 7, 4. So Katie can buy 7 plants, because X is plants, and the Y is bags of soil, so 4 bags of soil.